It's a pleasure to speak with you today. The Bureau of Reclamation is a federal water resource agency that operates and maintains hundreds of dams and reservoirs across the western United States. Today, the focus is on two reservoirs in western Oklahoma. These reservoirs are operated by the local water districts under contract with the Bureau of Reclamation. Lugert-Altus Reservoir provides irrigation water to about 50,000 acres of farmland. Tom Steed Reservoir provides regional drinking water supplies to about 40,000 people. Between 2010 and 2015, the area experienced a new drought on record, and both reservoirs reached the lowest levels in history, and the impacts were devastating. Groundwater and surface water are regulated separately in the state of Oklahoma, regardless of hydrologic connection. And surface water is regulated under a prior appropriation doctrine, essentially meaning first in time, first in right. Rights to the water stored in Reclamation's reservoirs are held by the districts and are senior to most, if not all, the junior stream permits in the basin. During the drought of record, questions were raised about the impacts of those upstream permits, as well as from groundwater pumping upstream of the reservoirs. However, the data and tools necessary to quantify the impacts and attribute the source of those impacts did not exist at the time. The Oklahoma Water Resources Board has planning and permitting authority over water in the state of Oklahoma. In 2012, they published their state comprehensive water plan that recommended strategies to address these gaps. In a tremendous act of leadership, Reclamation, the Oklahoma Water Resources Board, and the two water districts developed a collaborative partnership to address the recommendations in the state plan. In doing so, we initiated the Upper Red River Basin Study, and 7 years and $3.5 million later, we're finally nearing completion of the study this year. Using new ground and surface water models, we evaluated the impacts of various ground and stream water permitting scenarios on water availability in the basin. We were able to quantify the gap between supplies and demands, and we were also able to determine the causes of those impacts. This allowed us to develop solutions that targeted these sources. For example, here's an illustration showing permit availability for Tom Steed Reservoir, with blue indicating that there's sufficient storage in the reservoir to meet demands, and red showing that there's a shortage. To protect the reservoirs, one solution was to set conditions that reduce junior permitted stream diversions that protect the reservoir during drought periods to avoid these shortages. A key question was, how can we predict when those shortages are going to occur? We compared dozens of drought indicators, and using a variety of statistical techniques, we selected a combination of regional and local drought indicators listed here. We also tested the performance of these indicators in terms of predicting drought and non-drought conditions. 15 different drought scenarios were evaluated. The gray shading here highlights the occurrence of a drought, for example, based on each definition on a monthly time step over 90 years of observed records. We also tested a range of thresholds for each drought indicator. In the end, we selected the 4 inflow and PDSI thresholds shown here, alongside reservoir storage. The question now was, if stream permits were curtailed when these thresholds are met, how often would they be curtailed, and how well do they protect reservoir yield? Here's a graphic showing inflow over the period of record. The horizontal colored lines show when the 4 inflow thresholds have been met. Here's the same graphic for PDSI. The middle graphic here shows the timing and duration of permit curtailments over the period of record among the 4 thresholds. Although not shown here, results indicate that the thresholds can protect reservoir yield. Results also show that you can have the same protection of reservoir yield while curtailing upstream permits less often. In other words, all else being equal, the green threshold here would be preferred over the orange threshold. In other words, protect the reservoir, but not overly cut off diversions upstream. These are significant findings that could help achieve win-win outcomes in these river basins during the next drought. Switching gears, the graphic here shows groundwater wells in green within the alluvium in red upstream of Lugert-Altus Reservoir. We applied the same methodology used for stream water to identify thresholds that could be used to manage groundwater pumping. Although there are significant legal hurdles to overcome to do this, the results serve great value for future work in this area. The final results are being processed now. That concludes my presentation. I encourage folks to reach out to me if you have any questions. Thank you.